Welcome to qnawire.
Okay, so for this problem, it's going to be based on the previous problem, which is 3.35. So we could use information from 3.35 to solve problem 3.36. Okay, so in 3.35, we're given the width of the river, which is 500 meters. So our x value is going to be 500 meters. And we're also given that the river flows due south with a speed of 2.0 meters per second. So we could draw a triangle here. So the vertical length here is going to be 2 for the 2 meters per second. And it also says that the relative velocity to the water is 4.2 meters per second due east. So now we can draw another length here and assign that a value of 4.2 and give an angle here theta. Okay. Okay. So now we have a triangle set up. And for this problem, we're trying to find the direction so that the motorboat in exercise 3.35 will reach a point on the opposite bank directly east from the starting point. Okay. So in order to be directly east, I want it to go this way. Okay. So that's why this angle is relative to on the 4.2. Okay. So now our goal is to find the direction for A. So we want to find this angle theta. So we have a triangle here. So we can use sine of theta is equal to opposite hypotenuse. So it's going to be equal to 2 over 4.2. Okay. And now we can solve theta. So theta is going to be equal to inverse sine of 2 over 4.2. Okay. And if I compute this, I'm going to have an angle of 28.4 degrees. So that's going to give me the direction so that the boat goes directly east from its starting point. Okay. So now part B. Part B, I'm trying to find the velocity of the boat relative to the Earth. Okay. Okay, so if it's the velocity of the boat relative to the Earth here, I'm going to take the 4.2 and multiply by cosine of theta because I want the x direction then, because we're going east here, which is in the x direction. So I'm going to have 4.2 times cosine of theta and I calculate theta in part A. So I plug in the value of theta of 28.4 degrees, and then it gives me the velocity of the boat relative to the Earth. So this is going to be 3.69 meters per second. And it's going to be in the east direction. Because again, we were wanting to travel east here. And again, it's east because it's in the positive x direction. Okay, so what about part C? So for part C, it's saying how much time is required to cross the river. So note the velocity. So I'm going to velocity of the boat relative to the Earth. Is going to be equal to the distance x, because we want to know how wide the river is for x value. And that's going to be divided by the time. So I'm just using the general velocity equation here. So velocity is equal to distance over time. So I could solve for the time t. Okay, so now I can plug in the x value and give them for the problem. And I plug in the velocity of the boat relative to the Earth, which I calculate in part B, and it's going to give me the time. So the time I'm going to get is going to be 217 seconds. So it gives me the amount of time required to cross the river.